Hello guys, so today we'll solve EC2 exam questions. This question already came in the previous exams. So this will just gives you an idea of how the question will come and how to approach the exam questions. So let's start with the first question. A company deployed a 3-tier web application on Amazon EBS backed EC2 instance for a web and application tier and an Amazon RDS for the database tier. So here application will be having EBS backed EC2 instance for the web and application tier and RDS for the database tier. The company is concerned about the data loss in the web and application tier. So they're concerned about the data loss in web and application tier. So they're concerned about the EC2 instance. They're not concerned about the RDS. So let's see what will be the answer. Create an Amazon EFS file system and run a shell script to copy the data. So running a shell script will never be a good option for now. And creating a EFS file system will also not help you here. Create a EBS snapshot using CloudWatch event rule. That can be the possibility, but it's not explaining a lot. Create a Amazon S3 snapshot policy to back up the EBS volume. We don't have anything called S3 snapshot policy. Snapshots will be stored in S3, but we don't call it as a S3 snapshot policy. What D is saying, create a snapshot lifecycle policy that takes periodic snapshot of EBS volumes. That makes more sense. So here answer will be D, because D is making more sense and D is self-explanatory. Okay, you don't have to guess anything. Let's see question number 2. A company has a website running on Amazon EC2. The application DNS name point to an elastic IP address associated to the EC2. In the event of attack on the website coming from the specific IP address, the company wants to block that offending IP address. So they want to block the specific IP address. Okay, so here it should click in your mind that this question is from VPC and it's talking about the ACL, network ACL. Okay, which tool or service should a solution architect recommend to block the IP address? Using security groups, we can only allow the traffic. We cannot block the traffic. That can be done using network ACL. WAF and shield are something else that we have already discussed. Let's see question number 3. An e-commerce application is hosted in AWS. The last time a new product was launched, the application experienced performance issue due to enormous peak in traffic. Management decided that capacity must be doubled the week after the product is launched. We have to double the capacity. Which is the most efficient way for the management to ensure the capacity requirement are met? Okay, what will be the most efficient way? Step scaling policy, dynamic scaling policy, scheduled scaling policy, add EC2 spot instance. So here they're talking about the efficient way. So we have to think about the scaling actions. So D is obviously not an answer. We have eliminated D. Out of A, B, C, now step scaling, it means we'll scale 2, then 2 to 4 instance, 4 to 8 instance, 8 to 16. In this way, step by step. Scheduled scaling. What is scheduled scaling? It means, okay, from 9 to 5, I'll be scale up and then it will be normal. Will it help? No. Dynamic scaling policy. Whenever the traffic will in peak, it will scale up the EC2 instance. That is the most efficient way. Here in this equation, the most efficient way will be the dynamic scaling policy. A company is creating a web application that allow customer to view photos in their web browser. The website is hosted in US East 1 on Amazon EC2 instance behind application load balancer. The users will be located in many places around the world. Which solution should provide all user fastest photo viewing experience? So here your CDN should comes in your mind, because the users are located in all over the world and they want fastest photo viewing experience. First, it's very important that question should make sense to you. You should understand the question. Later on, you can able to solve the answer anyway. A. Implement the AWS auto scaling group for the web server instance behind the application load balancer. Enable CloudFront for the website and specify application load balancer as origin. Perfect. B is the answer here. Move the photo into S3 bucket and enable static website hosting. It's making no sense. So you can eliminate this one. Enable elastic cache in the web server. Why elastic cache come into the picture? Here the question is of the CloudFront. This question answer should be CloudFront. If you're not getting the exact answer, try to eliminate the other answer. Let's see question number 5th. A data processing application runs on an i3.large EC2 instance with a single 100 GB EBS GP2 volume. It's having single hard disk which is of 100 GB. The application stored temporary database in small database located on the EBS root volume. Okay, the temporary database is also located in this volume. Out of that 100 GB, that 30 GB is for that temporary data only. The application is struggling to process the data fast enough. Okay, and solution architect has determined that the IO speed of the temporary database is the bottleneck. So temporary database is the culprit, is the bottleneck. What is the most cost effective? Here we have to think about the cost effective. Maybe performance is not so good, performance and cost effective, but here specific they mentioned cost effective. To improve the database response time, enable EBS optimization on the instance and keep temporary database on existing volume. If I'll enable the EBS optimization, cost will be increased. Optimized EBS, okay, so cost will be increased. Put temporary database on new 50 GB EBS GP2 volume, but it's of less than 30 GB. Move temporary database to instance storage. That makes more sense because instance storage will be the cheaper, and even though it's a temporary database, it's a ephemeral storage. We have already discussed it in the EC2 section. Put the temporary database on new 50 GB EBS IO1 volume with 3K IOPS provision. Not making any sense. Here answer is C. A customer has a legacy application with a large amount of data. The file accessed by the application are approximately 10 GB each, but rarely accessed. However, when the file are accessed, they retrieved sequentially. The customer is migrating the application to AWS and would like to use Amazon EC2 and EBS. What is the least expensive EBS volume type for this use case? We want least expensive hard disk. So which one least expensive? I know HDD will be least expensive. HDD will be the lesser expensive than SSD. So B and C is already eliminated. Cold and throughput. So here cold HDD will be least expensive. Throughput will be performance oriented as compared to cold HDD. So it will not be the cheaper one. So answer will be A. Let's see question number 7th. A solution architect is investigating purchasing option for the batch processing application on EC2 instance. They're investigating for the purchasing options. The batch job download an image from S3 bucket, add copyright information and upload back to the S3. It normally takes 5 to 10 hours to process all the file uploaded each week. We need this each week if you'll properly read the question. The application has built-in capability to process the file in parallel, recover from the instance failure and continue processing from where it left off. What is the most cost-effective purchasing option for the solutions architect? Standard reserved instances. Now, reserved instances will obviously you have to sign a contract for 1 year or 3 years. We are searching for the cost effectiveness. It can be the answer, but let's see other options. Scheduled reserved instances. Here we'll be having scheduled reserved instances. We need every week. So yes, I can do that as well. Instead of standard reserved instances, scheduled reserved instances make more sense. Spot instances. Spot instances will be more cheaper than the scheduled reserved instances. So here answer will be spot instances. D will not be the option because D will be the costlier one. So answer is C. Now let's see question number 8. A company is migrating its data center to AWS. Okay, as a part of this migration, there is a 3-tier web application that has a strict data at rest encryption requirement. The customer deploy this application on EC2 using Amazon EBS and must provide encryption at rest. So this question is of encryption. How can this requirement be met without changing the application? A. Use AWS key management service and move the encrypted data to AWS. Fine. Use an application specific encryption API with AWS server side encryption. Okay. Use encrypted EBS storage volume with AWS managed keys. Don't you think this will be the simplest one? Okay. Use third party tool to encrypt. No, not at all. So third party in tools for encryption, that is not recommended. Okay. We already have the managed keys, and what we'll do, we'll use the encrypted EBS storage volumes. So here answer will be C. Now let's see question number 9. So question number 9 is basically not a technical one, rather than it's a kind of a logical. A team has developed a new web application in a AWS region that has 3 availability zones: AZ-A, AZ-B and AZ-C. This application must be fault tolerant and need at least 6 Amazon EC2 instances running at all time. So don't worry about the cost here. EC2 instance should be running at all time. That is the primary requirement. Forget about the cost now. The application must tolerate the loss of connectivity to any single availability zone so that the application can continue to run. So even though application lose the connectivity to one availability zone, there should be 6 instances running. Let's see the option A. AZ-A with 6 instance, AZ-B with 6 instance, AZ-C with no instance. If one will goes down, if AZ-A will goes down, we'll be having 6 instance in total. If B will goes down, again we'll be having 6 instance in total. If C will goes down, we'll be having 12 instance in total. This is meeting our requirement. We have to choose 2 answers. So currently A is meeting our requirement. AZ with 4 instance, B with 2 instance and C with 2 instance. Okay. If A will fail, the total number of instances is 4. We need 6. So B is eliminated here. C. AZA with 2, AZB with 2, AZC with 2. Here if one will fail, other it will make only 4 EC2 instance. So it will not meet our requirement as well. AZA with 3, AZB with 3, AZC with no instance. If A will fail, again total 3. A with 3 instance, B with 3 instance, C with 3 instance. If one will shut down, if one availability zone is offline, we'll be having 6 in total. So here answer is A and E. As I said, it's not technical, rather it's a logical one. Let's see question number 10th. A solution architect is considering possible option for improving the security of data on the Amazon EBS volume attached to the EC2 instance. Security of the data. They're concerned about security of the data. Which solution will improve the security of the data? Use KMS to encrypt the EBS volume. Create a IAM policy that restrict read and write access to volume. Migrate the sensitive data to instance store volume. Storage is a ephemeral storage. So C is obviously not an answer. Use single sign-on to control login access to EC2 instance. The question here, it's a security of the data, not accessibility of the data. There, how you'll improve the security of the data? So you'll improve the security of the data by KMS. Okay, you don't have to think about other things. It's not regarding IAM. The question is regarding the KMS. So you can secure your data by encrypting the EBS volume. And obviously, you'll be accessing the EBS volume when you will be having access to. So it's not of access. This question is of security. Let's see question number 11. A company is running a series of national TV campaign. These 30-second advertisement will introduce sudden traffic peak target at Node.js application. The company expect traffic to increase from 5 requests each minute to more than 5,000 requests each minute. Okay, from 5 requests each minute, it will reach out to 5,000 requests each minute. Which AWS service should a solution architect use to ensure traffic surge can be handled? Traffic surge, how suddenly when the traffic will peak? Till now what we did in EC2 only? Auto scaling. We automatically scale it. AWS Lambda? No. AWS Elasticache? Obviously no. If you know the Elasticache, it's caching for database, caching engine for database. Size of EC2 instance to handle the peak load. It will not help a lot. An auto scaling group for EC2 instance. from 5 each minute to more than 5,000, which is enormous peak in traffic. So it can be handled using auto scaling. So here answer will be D. Very simple question. Application is running on Amazon EC2 instance behind an application load balancer. The instances run in an auto scaling group across multiple availability zones. EC2 instances are in behind load balancer, and along with that we have auto scaling group. 4 instances are required to handle the predictable traffic load. Okay, we need minimum 4. The solution architect wants to ensure that operation is fault tolerant up to the loss of one availability zone. The same what we have solved in last question. Which is the most cost efficient? Here we have to think about the cost. So 4 instance should always be running, and we have to consider that what if one availability zone will fail, then also 4 should be running. So which one should I choose? Deploy 2 EC2 instance in each 3 availability zones. 2 plus 2 plus 2, total 6. If one will fail, total will be again 4. If any availability zone will fail. So this is meeting my requirement. My first option is only meeting my requirement, so answer is A. Let's talk about B, C, D as well. Deploy 2 EC2 instance in each 2 availability zone. If one will fail, we'll be having only 2 availability zones, 2 EC2 instances, not meeting my requirement. Deploy 4 instance in each of the 2 availability zones, 4 and 4. If one will fail, so we'll be having 4 instances in one availability zone. Okay, this is also meeting my requirement. We'll talk about this again. Deploy 1 instance in each 3 availability zone. Not at all, it's eliminated. So here A and C both are meeting my requirement, but here if we'll use A and C, we have to choose the cost efficient way. In total here, suppose the availability zone is not failed. How many instances are running? 6 instances. If availability zone is not failed, how many instances are running? 8 instances. So which one is cost effective? A is cost effective. So in that way you have to think. Okay, so let's see question number 13. A company has asked the solution architect to modify its AWS hosted internal application to allow for load balancing. Okay, the customer request always comes from the company domain. The company requires that incoming HTTP and HTTPS traffic is routed based on the path element of URL in the request. Which implementation can satisfy all requirement? So what is the requirement? Let me read it again. A company required that the incoming HTTP and HTTP traffic, the incoming inbound rule, incoming traffic is routed based on the path element. What is path element? abc.com/about us. So this will be the path. It will goes to the about us section. Now configure a network load balancer. Which load balancer should I choose? Which implementation will satisfy all requirement? Network load balancer, application load balancer, network load balancer, application load balancer. Here, so you should know if it's HTTP and HTTPS traffic, application load balancer will work here. Okay, we don't require a large we don't require network load balancer. Okay, so here option A and option C will be eliminated. Now we're pending with 2 options. So in this way you can save time. Configure application load balancer with host based on the domain field in HTTP header. What is the configure application load balancer with listeners? We have to configure the application load balancer and we have to give the proper listener for appropriate path pattern of the for the target group. So even though if you're not good what is domain field, what is HTTP header, choose the D. Suppose you're getting confused. I know a lot of guys will be getting confused here, but here you have to choose D. Choose the best one. Simple. In this type of scenarios, choose which is making sense to you. 90% of time you will be correct. Okay, but in case sometimes, because 1 or 2 or 3 questions you'll get it in exam which will make no sense actually, or which will be completely different for you. So here option D is making more sense. Suppose I'm assuming I don't know what is target group. Question number 14.
A media company asked a solution architect to design a highly available storage solution. Immediately it should click that maybe it's S3 to serve the centralized document store for their EC2 instance. Now it's a document store. Okay, the storage should need to be POSIX compliant. What is POSIX? We don't have to know about it that much. Scale dynamically and able to serve 100 concurrent EC2 instance. So it's a central solution. So can we give the EBS as a concurrent storage solution? No, what it can be. So if it's saying able to serve concurrent solution, able to serve the concurrent EC2 instance. So let's see what will be the answer. But here it should click without reading the option other storages and document store. It's saying so DynamoDB should also come in a mind, but it's not storage, it's a database. But let's see what other options are. Create a Amazon S3 bucket and store all the document in this bucket. Create a EBS volume and allow multiple user to mount the volume to their EC2 instance. Now this is not possible. We can use one EBS volume at a time. One EC2 instance can use one EBS volume at a time. Use Glacier. Obviously Glacier will not be the option, so B and C is eliminated. Create an elastic file system to store and share the document. Yes, we can do that. Okay, so here again we have to read the question because we have A and D. Now here it serves as a centralized document store. Okay, it serves as a centralized store for their EC2 instance. Here EFS can be the centralized store because it have benefits over the S3 buckets. Okay, S3 will be not that smart here. Okay, along with that it's POSIX compliant. What is POSIX compliant? You have to go through the EFS lecture, and dynamically scalable as well. This, even if you don't know what is POSIX compliant, it should be dynamically scalable. Now S3 is not dynamically scalable. S3 has a limit and it cannot go beyond that, but EFS can dynamically scale. So here answer is EFS. So in this way you have to answer the question. Let's see question number 15th. A solution architect must migrate a monolithic on-prem application to AWS. Now, what is monolithic? A big application, big chunk of application. It is a web application with load balancer, web server, application server, and relational database. The key requirement driving the migration is that the application should perform better and be more elastic. Which of the following architecture would meet this requirement? So they want to migrate the on-prem application. Now what on-prem application is containing? So load balancer, okay, we have load balancer. Web server, okay, we have web server. If it's a web server, I guess it's a web application server. EC2 instances will be there, and relational database RDS will be there. Let's read the question options now. Rehost the application on Amazon EC2 with lift and shift of existing application code. Configure an elastic load balancer to handle the incoming request. Use CloudWatch alarm to receive notification on scaling issues. Increase and decrease of the size of the Amazon EC2 instance using AWS CLI or AWS Management Console as required. Now it's saying to increase and decrease the scaling using CLI manually. Obviously that will not be a approach. So A is eliminated. Re-architect the application as a 3-tier application. Move the database to RDS. Use read replicas and Elasticache for RDS for better performance. Use application load balancer to forward incoming requests to web and application server running on-prem. Now here this will also not be the option, because what question is saying they want to migrate it to AWS, and what you're suggesting, okay, just be in the on-prem. They want to migrate it, they must migrate it to the AWS. So obviously this B will not be the option. Re-platform the application as a 3-tier application. Use elastic load balancing as an incoming request. Use EC2 for web and application tier. Use RDS for the database tier. Use CloudWatch alarm and auto scaling for horizontal scaling of web tier. Perfect. It makes complete sense. Okay, so I'll just stick to it for now. Let's read the option D. Re-architecting the framework as a service-oriented architecture. What is service-oriented architecture? We have discussed this in earlier videos. You can just go through it. Service-oriented architecture, web tier architecture, to two-tier application, three-tier architecture and all. Run database and application on servers on-premise. It's eliminated. We don't want to run anything on-premise. So here answer is C. Question number 16th. A company creates a critical 3D image every night. The images are batch processed every Friday and are required uninterrupted for 48 hours to complete. What is the most cost-effective EC2 pricing model? Now, cost-effective, most cost-effective. On-demand instance. Now, on-demand instance, whenever we'll use, we have to pay. So it makes sense. Okay. And so every night, that batch processing, every Friday actually requires for 48 hours from Friday to Sunday. Uninterrupted service. Yes, that will be there now. But on demand will not be the cost-effective approach. Here I'll eliminate it. Okay. Spot instance. Spot instance is cheapest one here. Okay, so immediately I should come to spot instance. It's the cheapest one, most cost-effective solution. But the problem is we need uninterrupted 48 hours, which is maybe not possible in spot instance, because if the bid price will increase, we'll lose our data, or it will get interrupted. At least it will stop. EC2 instance will stop. What is spot instance? You have to go through the EC2 lecture. So spot will not satisfy, it's cost effective, but it will not satisfy the requirement. Reserved instances. Yes, reserved instance, I'll get a discount over the on-demand instances. Okay, but there again, we'll be using it for 48 hours only. Then why we have to pay for 24/7? So that's why we'll be using scheduled reserved instances, which introduced later on after reserved instances. Now, what is scheduled reserved instances? I need it for 9 to 5. I need it for 9 to 5 daily. So what does it mean? First, I'll get charged for 9 to 5 only. Along with that, I'll get a discount of reserved instances. Okay, so on demand plus reserved instances. So scheduled reserved instances. Benefit of both. So here answer is B. Every Friday, because it's not a one-time job. So here answer will be B. An organization hosts 10 microservices, each in an auto-scaling group behind individual classic load balancer. Classic load balancer, old generation load balancer. Each EC2 instance is running at optimal load. Which of the following action should allow the organization to reduce the cost without impacting the performance? I want to reduce the cost at the same time. I don't want to impact the performance. Reduce the number of EC2 instances behind each elastic load balancer. Now, if I'll be having if I'll reduce the number of EC2 instance, so it will impact the performance. It will reduce the cost, but it will impact the performance. Change instance type in auto scaling group launch configuration. Now, instance type, that is nothing but a RAM plus processor. So here I can do that. Instance type is nothing but RAM. I can do that, but again it will impact the performance. Change the maximum size but leave the desired capacity of the auto scaling group. See, we have to change the maximum size, so that is also not optimal here. Replace the classic load balancers with a single load balancer. Are we using multiple load balancers? Each auto scaling group behind individual classic load balancers. Yes, we are using multiple load balancers here. So what I'll do, I'll replace multiple load balancer with a single load balancer, single application load balancer. So here answer will be D. Let's see question number 18th. A solution architect is designing a web application that is running on Amazon EC2 instance. The application stores data in DynamoDB. Okay, the architect need to secure access to DynamoDB. What combination of step does AWS recommend to achieve secure authorization? So what we want, let's read the question again. Designing web application that is running on EC2 instance. The application stores the data in DynamoDB. So EC2 instance should connect to the DynamoDB. So how it can be, so immediately it should click in your mind that it can be done using role. Option A, store the access key on Amazon EC2 with rights to DynamoDB table. That's access key, not at all recommended. Attach IAM user to EC2 instance. Now IAM user will not help here. Create a role with a permission to write it to DynamoDB. Okay, we can do that. We have to choose two options. Attach IAM role to the EC2 instance. Okay, attach IAM policy to the EC2 instance. We cannot attach policy directly. We have to go attach the role. So A and E is eliminated. So A, B, E. We don't use access key. IAM user will not help here, and IAM policy also will not help here. I mean, we can't attach it. So here answer is, first I have to create a IAM role with the basic permission what we want, and then we have to attach that IAM role to the EC2 instance. Here option is C and D. Okay, question number 19th. A web server will be provisioned on two EC2 instance with Amazon application load balancer. Which of the following configuration will allow traffic on HTTP and HTTPS when configuring a security group to apply to each servers? So which of the configuration will allow HTTP and HTTPS traffic? And we have two EC2 instance with a load balancer. We have already performed this. Allow all inbound traffic and explicit deny on non-HTTP and HTTPS port. In security group we can only allow, we can't deny, so A will not be the option. Allow incoming traffic to HTTP and HTTP ports. We can do that. Allow incoming traffic to HTTP and HTTP ports, okay, with explicit deny to all other ports. Again, we cannot deny in security group. Deny all traffic to non-HTTP and non-HTTPS port. Same, we cannot deny. So option will be B. Will only allow the traffic to HTTP and HTTPS port. Let's see question number 20. A customer is running a critical payroll system in production environment in one data center and a disaster recovery environment in another. It's running one production environment in a data center and disaster recovery environment in another data center. The application include load balanced web server and failover for MySQL database. The customer's DR process is manual and error prone. For this reason, management asked IT to migrate the application to AWS. Again, they want to migrate the application to AWS, make it highly available so that IT no longer has to manually fail over the environment. So earlier it was failover was manual. We were having DR and production environment is in one region. Migrate the production and DR environment in different availability zones. Yes, perfect. I can do that. Different data centers, availability zone, but nothing but the data centers within the same region. Yes, let AWS manage the failover between the environment. Yes, perfect. I can do that. So I'll reserve A for now. Migrate the production and DR environment in different region. No, that will not be the good approach. Okay, let's AWS manage the failover between the environment. It will be multi-AZ deployment, not multi-region deployment. Okay, the two different data centers are anyway isolated with each other. So I'll choose A over B. Migrate the production environment to a single availability zone. No, I don't want to migrate the environment in the single availability zone. Okay, so even I'll not read the whole option. Migrate the production environment and span it multiple availability zone using elastic load balancer and multi-AZ RDS, Amazon RDS. Decommission the DR environment because it's no longer needed. Now if you'll see, till now A was my option. Now D make more sense because D is explaining more actually. If you'll see, we have to migrate the environment, production environment into the multiple availability zone. Now what will happen when you'll migrate it, it will be span into the multiple availability zone. So if one zone will fail, another zone will come into the picture. Using elastic load balancing, we'll be using elastic load balancer and we'll use multi-AZ RDS instance. So both everything is explained properly here and it's correct as well. So here we'll be using option D. Let's see question number 21. A solution architect is designing a highly available web application on AWS. The data served on the website is dynamically and is pulled from Amazon DynamoDB. They're designing a highly available application. The data served on the website is dynamic and pulled from the Amazon DynamoDB. All users are geographically close to one another. How can solution architect make the application highly available? So till now what I see is we have to deploy multi-AZ deployment. Host host the website on Amazon S3. Website is dynamic. Don't read further. That is not the answer. Host web server data on CloudFront and update the object in CloudFront distribution when they change. But CloudFront the data is of DynamoDB. It's pulled from DynamoDB. Okay, so maybe CloudFront will not in use. Let's see other options because I'm not too satisfied with the option B. Host the application on EC2 instance across multiple availability zone. Yes, use the auto scaling group coupled with the application load balancer. Makes sense, right? Here they want to make the application highly available. So here C make more sense. Let's see option number D. Host the application on single availability zone. Now, if it will be single availability zone, the application is not highly available. Okay, replicate the EC2 instance to separate the region and use Amazon for high availability. So here I'll not go with D because they want to host the application in single availability zone only. Okay, so here answer will be C. Let's see the last question of EC2 instance now. A company has many applications on Amazon EC2 instance running in auto scaling group. We have multiple instances, EC2 instances running in auto scaling group. The company policy requires that the data on the attached EBS volume must be retained. They require that the data on attached EBS volume must be retained. What action will meet the requirement without impacting the performance? So the data in EBS, how we can back it up using snapshot. I'm not going through the option till now. Now, enable termination protection on EC2 instances. Disable delete on termination for EBS volume. So if I'll enable the termination protection, I'll not be able to delete the EC2 instance. Okay, I'll not be able to delete the EC2 instance. Disable the delete on termination for EBS volume. Now, if I'll disable delete on termination, so what will happen? If I'll delete the EC2 instance, EBS volume will still be persist. EBS volume will still be there. So B is better than A. I'll choose B over A. What other options are? Use EC2 instance user data to set up the synchronization job for root volume data. Okay, so that's user data. It's not making a lot of sense here. That yes, whatever the data will be in the root volume, we have to secure that. But how user data will help here? No, it will not help. So C will not be the option, and I'll choose B over A. So A is also not the option. So C and A is eliminated. Change the auto scaling health check to point to the source on root volume. Now how this will also help me? Okay, this will point to the root volume, but how I want to save it? I want to secure it. I want to secure the EBS volume. So that will be possible using B. Other are making no sense. Okay, other options are making no sense. So here I'll choose option B. So that's all for today, guys. We'll see you in the next lecture.